And that was actually the Milky Way. Now, in Singapore, in fact, you can't really see the Milky Way, and that's because of our light pollution level. Okay, our light pollution level is usually at a 9. Okay, and if you can see the chart, the lower the number, the lesser the light pollution. And when you have a low light pollution, the sky actually becomes more and more visible. All right. So before I start the chapter, I would like to go through a quick introduction of what light does for us, right? And that actually we need to compare the night sky. Okay, this is a photo taken um, in the exact same location. Okay, and you can see the difference between the night sky. Okay, one is with light pollution here, and one is without. And when it's without, it actually looks amazing. Okay, so actually the night sky is amazing. It's just a pity that with light on the streets, we actually can't see light in the sky, right? And this is a photo of the moon taken in Singapore, taken just at the void deck of my house, right, with a DSLR. So actually, if you adjust the light setting, you can actually take a picture of a moon. And there are a few interesting points on the moon. For example, the different gradients. Okay, over here is an interesting point also. It's an orange, and it has like multiple peels across it. Okay, so if you have time, yeah, just go and Google about the moon. It can actually be quite interesting. Okay, I went for a Malaysia trip a while back, and I actually spotted the Milky Way. If you can see, there's a white color layer over here. All right, that is the Milky Way. Of course, it's not very clear because same thing like pollution. Okay, it should actually look like this, but what I have is actually just this, right? Okay, so this is the Milky Way when light pollution level is low. Okay, this is a star cluster. So something like this little spot here, right? It actually looks like this on the camera, and all the white and yellow and red dots you see here, they are actually a cluster of stars. Okay, so can you imagine just one little small dot in this picture actually results in so many stars, yeah, and therefore there are like millions of stars in the universe. Okay, now one last thing before I start. Okay, so this is a picture of a moon. Of course, it's not a full moon, you only see a crescent. But what are these? They are actually planets. Okay, so you can in fact see planets in the sky with your naked eye. Okay, you don't need a telescope, yeah, unless you want to go into detail. Okay, so usually the brightest object in the sky, they are actually the planets, apart from the moon. Okay, so moon is first, followed by planets, followed by stars. And that's because stars are like super far away from us. Okay, they are really far. Okay, the closest things to Earth, right, apart from the moon, right, is going to be the planets really. And the reason why planets give off light is not because they give off light, it's because they are reflecting light from the sun. And that's actually our first subtopic as well, reflection. Okay, so they actually reflect light from the sun, and as they reflect light from the sun, they reflect it to Earth, and that's why they appear as bright in our sky. Okay, now so we will go on to reflection, and we actually start the chapter, right? Okay, now over here you actually realize that the water actually shows a reflection on a mountain. Okay, we call this regular reflection, a reflection that is very common. So when you look at the mirror, you see your reflection, that is a regular reflection. Okay, now I'll show you a few more examples. Of course, this is not a very good example. This is because the light is too bright, but if you adjust the light setting, you actually do realize that it's going to portray a regular reflection. Okay, same goes for this. You realize all this light, they are being reflected from the HDB houses, okay, which portray regular reflection. So actually, what causes reflection, and how does reflection really work? Okay, so let's talk about regular reflection first. Reflection that is very common to you. Okay, so whenever you look at a mirror, you actually experience regular reflection. And how regular reflection occurs is because there's a light shining on a smooth surface. So this is a surface, could be your mirror, right? And after that, they are reflected. Okay, so long as the light coming in the same direction. Okay, so we call this incident ray first. So long as light coming in parallel to the incident ray, okay, are being reflected in the same way. So what's going to happen is that we have rays that are parallel to one another. in this manner, right? We call these incoming rays, we call them incident ray, okay, and they are being reflected in the same manner. So you will realize that what actually happens is that you're going to get a lot of light rays going in the same direction, okay, and that actually is called a regular reflection. Okay, now there are a few things to note in a ray diagram like this. Okay, first thing, we have to draw arrows to portray how the light is traveling. So it's coming down from the incident side and going up on the reflected side. We call them the reflected ray. Okay, in an actual diagram you actually just need to draw one, okay, but just for illustration purposes I'm drawing three in this notes, okay, to show you how it really is like. Okay, in fact there are millions of light rays, okay, so drawing one is okay, drawing three is just to show an example, but if you really want to draw, you're going to draw a million, okay, so obviously that's not needed. Okay, now the opposite of regular reflection then is called diffuse reflection. Okay, so as the name suggests, diffused means it's going to go everywhere. Okay, so let's say I have a rocky ground. Okay, so what happens is I have rays that are parallel to one another, yet the reflected outcome is not going to be the same. Okay, so they are parallel to one another, okay, yet the reflected outcome is going to be different. Okay, first let's go back to the regular reflection part and take a closer look at what's actually happening. Okay, so I'm going to redraw the diagram, okay, over here. Okay, we will call this the proper ray diagram, right? In fact, we can call it the basic ray diagram. This is how it will look like. In a basic ray diagram, you actually have a surface. Okay, so I have a surface here. Now, we will have a line that is perpendicular to the surface. We call this line the normal. Okay, basically normal just means a line that is perpendicular to surface. Okay, so if I have a normal to the surface, it's a line perpendicular to that surface. Okay, so this is 90 degree. Okay, I'm going to not write that to avoid confusion. Okay, next up we have the incident ray. Okay, so this is the incident ray. So we call this incident ray, and we actually have the reflected ray somewhere around here, right? Of course it goes further, okay, but I just don't want to confuse you all, so there's no intersection, but it can go further. This is the reflected ray. Now over here there are a few things to label. First is this we call it the angle of incidence. Then we have another angle R, we call this the angle of reflection. Now there is a law, the law that states that the angle of reflection, or rather the angle of incidence, is equals to the angle of reflection. Okay, so that if this angle is 30 degree, this has to be 30 degree as well. So that's what the law means, okay, when they say the angle of incidence is equal to the angle of reflection. Now there's another thing I want you all to take note, the angle that I'm referring to, right? How do I actually get this angle, right? So I have two angles, the angle of incidence and the angle of reflection. Now I'm going to show you, we have to write down that this angle, the angle always refer to the angle always refers to the angle between ray and normal. Okay, so this is something that you all need to take note of. It's between the normal and the ray. Okay, so this is my reflected angle, this is my incident angle. Okay, I don't want to see anyone labeling it in this manner, okay, because they are not supposed to be there, right? Okay, now back to diffuse reflection. So how do I actually draw the diagram for diffuse reflection? Now first thing first, let's take a look at the first ray. I have it here. what will happen is I'm going to draw a tangent to this surface, and then I draw a normal. Okay, so the normal looks like that. Then I apply the angle of reflection. So what happens is it's going to get reflected, and the angle of incidence is equals to the angle of reflection, and therefore it's going to look like this. Okay, so same thing, I'm going to do the same thing for here. There's a tangent here. I draw the normal, something like this, and then the angle, the reflected ray will actually go in this direction, right? And finally, last one, I'll draw the tangent, looks something like this with the normal here. Okay, and then you have the angle of reflection, somewhat like this. Alright, so in all these diagrams you realize that the angle of reflection and angle of incidence, they are all equal. Yeah, yet all the rays are all pointing in a different outcome. Okay, so that's what I mean by diffuse reflection as compared to regular reflection. So you see, one has an outcome where all three rays are pointing in different direction, that's diffuse reflection. One, I have all the rays pointing in the same direction, that's regular reflection. Okay, and this is a basic ray diagram. Please do take note of the details that I went through over here. Okay, now let's go to how a reflection actually creates an image. Okay, so for that to happen, first we need to understand the characteristics and the diagram. Okay, so let's draw a diagram first. So what happens is that you have a mirror, right? And then you have an object. So let's say this is a ball and this is my object, right? So what's going to happen is I have a ball. Now the first property of an image is the image will actually be formed on the mirror, but what will happen, what will be seen is that it actually is equidistant. Okay, in other words, this distance here is equals to this distance here. Alright, in x is equals to y. Okay, they are of the same distance. Next, my observer might be looking from here. So what will happen is that he will actually see the image, right? Because that's what you all see. Okay, so I'll actually see the image. So what will happen is that in fact there will be seemingly as though like there's lines coming out from the image into your eyes, right? So they are coming out from the image into your eyes. Okay, note two things. First, I didn't misdraw. The dotted lines are there intentionally. Okay, so do take note which part is dotted and which part is solid. Okay, so you realize in the mirror, lines are dotted. Why are they dotted? Because they don't actually exist. Okay, now your mirror can be like, I don't know, 3 cm thick, you know, yet it can detect as though your reflection is 4 meters away. Obviously you are not 4 meters behind the screen, yeah, on the screen itself, right? Yeah, on the mirror itself. So obviously the mirror doesn't have a depth of 4 meters. Okay, so when you see an image, it actually doesn't exist. Yeah, it's just what you see. Okay, so they don't actually exist, and therefore I draw it in dotted lines. Okay, dotted would mean that they don't exist. Okay, so what do I draw next? Okay, so these are actually my reflected rays. Okay, please take note of the direction. The rays are actually going into the eye. Okay, not the other way around. Okay, you don't produce light from the eye. Okay, now the light has to come from somewhere. The light actually comes from the object. Okay, so when you take a light source and you bring near the object actually reflects light, and the light goes to your eye. Okay, so the incident ray should come from the object. Okay, so the incident ray is a real ray, so it's going to be like this. Okay, so this is the incident ray. Okay, in a short summary, these are the 4 steps that are to be taken. Number 1, draw image. Right, so this is the image. Remember that they are equidistant. Number 2, draw reflected rays. Okay, note dotted lines. Okay, number 3, draw incident ray. And number 4, apply the law of reflection. Okay, so how do I apply the law of reflection? Now over here I'll draw two normals. I need to make sure that my reflected ray, the angle of incidence is indeed equals to the angle of reflection. So do a check and make sure that the angles are actually equal. Okay, so if they are not equal, you might have to redraw. Okay, so please draw the normal and then apply the law of reflection. Oh, and number 5, please take note, draw arrows. Okay, so please take note that the arrows actually come from the incident ray and then to the reflected ray and then into your eye. Okay, not the other way around. Okay, so this is how you actually determine how to see an image. Okay, and there are a few characteristics that we need to take note of an image. Number 1, it is equidistance. Okay, that means same distance as the object is to the mirror as the image is to the mirror. Okay, number 2, it is always upright. Okay, so if you stand upright and look at the mirror, the image is also upright. Okay, number 3, it is laterally inverted. Okay, so go to the mirror, raise your right hand, you actually see that it actually raises its left hand. Okay, so that's laterally inverted. Number 4. Okay, now the laterally inverted is something cool. If you do realize what I mean, then it actually also means that you have never seen your real self in the mirror before, because that's not how you look like. Yeah, your left side is your right side, your right side is your left side, so you don't actually know how you actually look like. Okay, number 4, through a mirror, of course. Okay, so number 4, it is virtual. Okay, so virtual means that it cannot be captured on a screen. So what do I mean by cannot be captured on a screen, right? So a camera does not produce a virtual image, because a camera can produce an image that can be captured onto a screen. Okay, you can actually plant that image onto a screen, but for mirrors, right, they actually don't. Okay, so if you look at yourself and you walk away, the image of yourself shouldn't be there still. Okay, if it is, then I wish you all the best. Okay, yeah, please do not tell me anything. Okay, and number 5, the object is actually same size. Okay, so if you look at a mirror, what you see is what you get, unless they use a different mirror. Okay, so we will talk about that in the later part of the chapter. We talk about concave and convex mirror that departmental store use to make you feel like you look good, but in fact, then when you go home, right, and then look at the mirror, you realize, why did I buy that dress, right? Okay, so these are the 5 characteristics that you need to know of an image formed by a plane mirror. Okay, now that's for reflection, and now we'll go on to the next part, which is actually refraction. Okay, so I want you all to watch a video again. Now in this video, what you see, right, is actually a glass disappearing in glycerin. Okay, and then we'll talk about why it actually disappears. Okay,